Now, guaranteed, there are things you can do with the tuple type that you cannot do with the list type. For example, you can use it as the keys of a dictionary. Why would you want to do that in the first place? Well, think about this. You have some dictionary, some mapping that maps between entities and some corresponding values, experiments and the experimental results. Entities you're managing and some configuration data for those entities, or some process or some steps you want to do for those entities. Users and their parameters, their settings, their configuration items. And you could model it in either of these two ways. You could model it as the entities just encoded as a string, or you could model as the entities encoded as a tuple. Note, there is an in-band encoding here, where one entity ends and the next one begins. May be difficult to disambiguate if the entities can also have commas in their names. Is this 3 entities, A, B, C, and D, E, F? Or is it 2 entities, A, B, C, and D, E, F? And without some sort of partitioning, or some additional metadata, some external metadata, or some sort of escaping, we may not be able to tell the difference. Whereas here, it is clear this is actually 3 entities. From a practical perspective, one thing that we might think is, do we look at the keys of a dictionary and we understand the data that's stored within those keys? Do we ever destructure that data? So ABC, DEF, is that just an opaque entity to us and we never take that apart and say, oh, tell me all the different components of this? If not, then maybe the first formulation is perfectly fine. If so, then definitely we want the second formulation, because in the second formulation we could do something like for the X and the Y portion of the keys here, look at those separately and tell me what those 2 pieces of data are. And maybe, compute the Cartesian product of ABCDEF and ABCDEF XYZ and look at all the different ways that these might appear. There is another possibility for what we might put in this dictionary, which is a frozen set. And in the frozen set scenario, we want the structured data that's stored within that key. We want to be able to dismantle that structure, but we want to do that in a way which is no longer order dependent. In this example, in the first example, the value for ABCDEF doesn't have to be the same as the value for DEF ABC. Whereas in the later example, because the frozen set isn't an order type, a human order type, it's a machine order type, and where that ordering is not considered in the cases of the hash or the equality, these two would be the same. Let me give you a scenario where this might occur. What if this is a mapping between components or between devices and steps you need to perform on the device? Or maybe, what if this is a mapping between users and what groups those users belong to? Is the group that ABC and DEF belong to the same as the group that DEF and ABC belong to? Yeah, there's no ordering there. That's why you might want to use a frozen set. Why you might want to use the tuple is there's maybe some sort of sequence or there's some particular ordering that's necessary. And so, in the case of ABC and DEF, maybe ABC represents the manager and DEF represents the subordinate. And so the group where ABC is the manager for the project and the DEF is the person who's working on the project is definitely different than the one where DEF is the manager for the project and ABC is the one who's working on the project.